You don't know me, my name is Ryan Sochol, and I'm an associate professor in the Department of Mechanical Engineering. And then, as of like last week, also the Institute of Systems Research, as I recently became the interim director of the Maryland Robotics Center. And so I'm also associated, I'm a Fischel Institute Fellow within the Robert E. Fischel Institute for Biomedical Devices, and have an affiliation with the Department of Bioengineering. And so today I'll be talking about one of the courses that we released a couple years ago and are still developing and working on, that I think is pretty unique and fun to hear about. And so I'll share a little bit of what we've been doing there. I think kind of as a general, introduction, I'll kind of just kind of talk a little bit about like where this all came from. And so there's a concept that I personally am a follower in, which is called temptation bundling. And if you haven't heard of it, I'll just kind of give a brief overview. But basically, there are activities in life that one could refer to as, kind of these want experiences that, you might really enjoy, doing them in the moment, but then afterwards you feel kind of guilty for having spent your time that way. So one example would be watching like my favorite TV show. So I could spend a lot of time like watching TV, and I might enjoy it in the moment, and then afterwards I feel, like maybe I could have been doing something differently with my time. On the opposite side, there are what are referred to as should behaviors. And these are things that maybe, you don't enjoy a ton as you're doing them, but then afterwards, like you feel really great that you did that. So kind of the opposite of guilt. And one example of that would be like working out on a treadmill. And so the idea behind temptation bundling is basically to combine these into a singular activity. And so for me personally, I have certain TV shows that I do not allow myself to watch unless I'm on a treadmill and running at the same time while I'm watching. And so kind of by bundling that, I'm more motivated to do those should behaviors than I would be. And I've tried to kind of take this philosophy and implement it, both in my research and education activities. So on the research side, I'll share a little bit about this just very briefly. In I work in this area called soft robotics, and oftentimes if you make a soft robotic hand, the standard way to demonstrate that it works is to have it play piano, just some song on the piano. So one of the issues that I felt about this is that one of the problems is that if you make a mistake, really nothing happens. Like, yeah, it sounds a little bit weird, but it's not, that big a deal. And then the other thing is that you can kind of choose the song or the tempo that you're doing and how fast it's going, just based on what you think your hand is capable of. But there's another part, in terms of motivating my researching students, was that I don't know if I view playing piano as a guilt-inducing want experience. I think, I personally grew up where, playing piano was something my parents were like, Ryan, you got to go and play piano for X number of hours, that kind of thing. And I don't think I felt guilty playing piano, after that. So what we ended up doing was we decided to demonstrate our soft robotic hand by playing Super Mario Brothers on an emulated original Nintendo Entertainment System. And so there's some benefits here. So one, from a scientific point of view, right? If you don't press the right button or whatever, you run into a Goomba, you fall down a pit, and it's over. Also, the timing, you can't change that. Everyone knows what the levels look like, and so it's more standard. But the other reason is it was a type of temptation bundling, where basically my students would, want to come into the lab because they see the Nintendo in there and so forth. And so kind of it is an adaptation of that concept. And so I'm kind of always interested in how can we apply this concept of 10 patient bundling in other areas, and especially in engineering education. And that's kind of what motivated what I'm going to be talking about today. So in education, there's this concept of game-based learning, where basically people use a number of different types of games and general strategies associated with games in terms of like rewarding accomplishments and so forth as a way to kind of engage students in learning. I'm particularly interested in video games, just me personally. That's something that I enjoy, and so I kind of focused in a little bit on that. And there are a number educators who have looked at this potential before. Most of them revolve around what are referred to as serious video games. And these video games, the only purpose is education, is it was designed for academic learning, often by the educators who are going to be using it in their classes, things like that, to see if it can engage students differently than just lecture, that kind of thing. And then there are also commercial educational games. So it's possible that some of you have heard of Kerbal Space Program, where that's one of the more popular ones. Minecraft actually has an education edition. And so that is kind of something else that has been employed. But again, these are focused specifically on being designed for education. And then there's also this concept of taking kind of like entertainment games and then creating modifications or mods of those games. And so Minecraft is one that this is an example from a team at Purdue University who basically created this modification of Minecraft to be able to teach mechanics of materials to students. But again, this does require, the educators making their own changes to the game. But for me personally, I was really interested in if we could use just straight entertainment video games, the ones that are designed for entertainment. They're not designed, for education in mind. And there was actually a review article that had come out a couple years ago where they talked about this, and they mentioned just the historical challenges to this, where and typically, when it comes to parents, entertainment video games have what they refer to as a bad reputation. Um, I don't know for some of you if you remember the days of early Mortal Kombat and how Congress reacted to that and came out with ratings for games and everything. But for a long time, kind of parents on one side versus video games. But there have been a lot of interesting studies coming out lately of the benefits of certain types of entertainment video games in terms of the cognitive benefits. One example is using 3D video games. So people who play video games with like 3D environments, like this one that I'm showing with Mario 64, where it actually helps to stave off things like dementia and so forth. These are like loosely studied, so don't quote me on any of that. But those are the kind of things that have started to come out. And so, there's this question of could entertainment video games also improve academic skills? And then they finish the the article by basically saying future studies need to investigate, this potential of entertainment video games' practical value in education curricula. And so we took that pretty seriously. And so my involvement with this really happened when this particular video game, The Legend of Zelda: Tears of the Kingdom, came out in mid-May of 2023. And so this was one of the fastest selling games at the time. It was the fastest ever for any Nintendo game. It also had fantastic ratings from critics and users alike. It won Best Action Adventure Game at the Game Awards. But the thing that was kind of wild when I first started playing is we got it the day of, and actually one of my colleagues from the Army Research Lab, so he brought his family to my house, and we all played the game together. And very early on, both he and I kind of looked at each other and we're like, this is work. This feels like something that I've been training with my experiences using computer-aided design. It's the same stuff that's actually in the game. And another part is that the physics of the game are surprisingly accurate. There are inaccuracies, but genuinely, so this particular example you can see here, you can see the physics of how how the bridge is moving and so forth, is surprisingly sophisticated. And also, there's different things that you build in the game that even have battery usage associated with them, where you have to kind of balance, which components you use and how much energy they require and so forth. And so we thought that this could be like kind of a really unique opportunity to develop some type of educational endeavor around machine design within this particular game. And these are some examples that like that first week or so that the game released, people were already starting to build relatively sophisticated robots within the game. And posting them like on Reddit. And actually, I use these as examples to help convince the higher ups to let me start this course. And so that's the overview of the course. So the game came out in May. Then I spent the summer, one, trying to beat the game because I didn't want to teach it without having beat the game. And that was like actually pretty rough. And then two, developing, the full course and the syllabus and the projects and everything for that first semester. And so I'll talk a little bit about that and also how it's gone since then. And I'm going to be just as a additional mention, I'm going to be including results that we've reported at the American Society of Engineering Education annual conference in 2024, and also 2 weeks ago in 2025. And so one of the questions I usually get is, well, what's the breakdown of the class? And this is something that caught me off guard. In my head, this was, I assumed everyone was going to have a lot of experience with Zelda. But actually, over a third of the initial students, so we had like a randomized lottery in terms of who gets accepted into the course. We had a lot of people who initially tried to get in, and more than a third had never played any Legend of Zelda game in their entire life, which that really caught me off guard because it's been around since the mid 1980s. And then the second one was that a bunch of people hadn't played this particular game before. And that made a little bit of sense because the game had just been released in, I think, like May. And so this was like the fall semester. But still, over half the class had no experience with the game. That was a surprise and also a challenge because it meant that I kind of had to restructure my syllabus to just get the fundamentals in, before they could start really building robots. The breakdown, is always rough with in engineering. This particular, 2/3, people identifying as men and 1/3 identifying as women was it's actually better, unfortunately, than what we typically see in mechanical engineering. But that, yeah, it just is where it is. All right, so I'm going to show a little bit about just like the process of what the class looks like at the moment. And so on day one, we actually do this thing where everyone kind of lines up. It's kind of like kickball as a kid. And but we don't do like team captains or anything, but we ask, who here has beat the game? Certain people raise their hands. They get split up into different groups. Who here has played more than 20 hours with the game? And then they, and so forth until each group is relatively balanced. And then we pass out one Nintendo Switch to each team, which they're allowed to keep for the entire semester, as well as the game cartridge and a Pro controller that's just more intuitive to use, I think, for adults. And these are some of the students, and you can kind of see the layout of where the course is taught and so forth. Then we move on to phase one of the course. There's 3 phases. So phase one is that basically actually inside of the game, there are these they're called shrines, but basically they're just problem solving challenges where people have to figure out, in this example on the right, where do you have to put these different block-like elements and kind of glue them together? And then where do you glue the different fans so that they propel you to be able to go through this part of the course? And as a result, just I've designed the syllabus to only go through the particular parts of the game that teach you how these particular components work and also teach you how to use them for problem solving challenges. Then we move into phase two, which is a midterm project where the students do investigations of each of the machine elements. So for the students here who are showing their investigations of the spring, where they combine them in tandem and what happens. And they also actually have to model them using traditional computer-aided design software. One of the things that the students also present is their analysis of how the components work in the game versus how they should work in the real world and what are some of the differences there, which is kind of fun, I think, to see. They deliver a relatively short presentation, typically under 10 minutes per team. And then they all have to, so all of these images that you see to the left, that students together collectively have to submit all of these actually as actual CAD models that can be shared with everyone in the class. And so that's kind of an interesting thing. And I'll show some examples of deliverables in a little bit. And then the last part is my favorite part. And this is where we have a final team design challenge where the students build a transforming bio-inspired robot. And this is because there's a functionality in the game where once you build a machine, you can save that and you can recall that to automatically build that machine. And so what we do is we have this rule where you can choose up to 21 machine elements like motors and propellers and wheels or whatever that might be, but they have to be used in both states so that you have one part of a course, that you race a certain way and then the next part. And I'll show an example of that from this recent semester. And then the course ends with basically on the last day, a short 5 to 10 minute presentation where they cover what they've done. And then we end with a live in-class race where basically the team that completes a set course the fastest, they get an A plus. And then the team that comes in last, they also get an A plus because this is a 1 credit course. So I mean, yeah, we're not too harsh. The only way to do quite poorly in my class is based on feedback from teammates. And so if the teammates, don't give someone an enthusiastic review, that's where the grades kind of end up dropping. All right, so bio-inspired robot, what was our most recent example of that? I'm going to show that here. I made a tremendous mistake. And I thought this would be a really cool project to do a transforming flying monkey inspired robot from The Wizard of Oz. I'll show a little bit of how that went. But the idea was that on land, it has to have, bio-inspired movement. So this thing that you're seeing here is supposed to look like a monkey, or an ape kind of moving. And then once you get to a part of the course, it's supposed to basically, it reconfigures all of it, and then it's supposed to fly and defy gravity. But yeah, all right. So that's our goal for the semester. Quick show of hands. Who has watched Wicked, the movie? I'm gonna be spoiling some stuff in a second. All right, who has watched Wicked the musical? Better question. Who has never watched anything Wicked related? Well, we're gonna get into it this course. All right. So I really miscalculated this. So I really enjoyed Wicked. If you haven't seen it, I think it's tremendous. But it turns out that like the Venn diagram of people who take my course and then people who have seen Wicked is like, I guess I'm the only one that it overlaps with. Lesson learned. I still think it was a good example to try. So there's something we've recently been studying is basically just, can we use entertainment video games to enhance student motivation and engagement, and ideally learning outcomes. I'm going to show a little bit of the results, and I'll get into some of that soon, but just to show a little bit of some of the deliverables. This was from that very first semester. So that one was you have basically, it's a walking robot on land, and then it's an aquatic vehicle in the water. It's supposed to swim. But I can show you a little bit here of just, so on the far left is the land-based configuration. The students said that it was meant to be like a road runner. And then you can see exactly how it transforms in the middle from one state to the next. And on the right, you can see the swimming configuration. I forget, it was some kind of lobster that they showed a video of a lobster moving like this. I think it, I think it's fine. I think it definitely looks like something you've seen, maybe like a free stroke or something, freestyle swimming.
On your marks, get set, go.
So that was the race for that part. So originally, actually, the amphibious robot was a midterm project, and then we had actually a second final project, which is this an aerial catapult. So you can see here. So this is actually a three-component system, and they basically it goes up, it loses something, they hit a stabilizer, and then they have a third part, which is now they hit this, and it has to shoot this little thing through the ring, and you see it like right there at that little moment. This was way too much work for a one credit like course, and so after that first semester, I adjusted it. We got rid of the aerial catapult, and we basically only have the bio-inspired robot as our final project. But I still thought that this particular team did amazing. So the other thing is kind of getting back to where the course currently is. So these are some examples of that midterm project, the current midterm project, where they have to basically model the in-game components using their own computer-aided design software. And so I'm showing some examples here of just, what the students put together in terms of these designs. This is what this is a motorized wheel in the game, and this is the CAD design. You can kind of see the detail that the students were putting into this. And then this is one of the larger motorized wheels in the game. And then this is the CAD design that they came up with. And then they even like illustrate, they added like textures to it and colors to it. And the main thing I want to point out is this is not part of the assignment at all. There's no part of the assignment that says they have to do any of this. Really, it's just meant to be the basic model so that other groups can kind of use it in their own CAD assemblies. They didn't have to do any of this stuff. They're putting it like on a background with like nice, images and stuff. And so we ended up seeing that just a lot of students end up going like above and beyond what was asked when it comes to deliverables with this course, which is something that's like always awesome to have happen as an instructor. This is one of the other students, or one of the other student groups where they had put together their monkey-inspired robots. You can kind of see it's supposed to have that, that kind of motion. The flying version, I think, was a little bit tougher. So one of the other things that I hadn't really mentioned yet was also we asked them to show side by side. How would you build this in the computer-aided design software? So that's what you're seeing on the left. And then how do you build it in the actual game? Just to show how analogous it is, but also just to give them more practice, right? These are second year students. They're at the very beginning of their second year. And we just want them to get really, really, really good at computer-aided design because it is so fundamental to many, many areas of I would say anything engineering. For my research in 3D printing, like it's incredibly fundamental. So very important. And then this is one of their examples of the flying robot that they did. I don't know if this looks like a flying monkey in my opinion, but it does, it flaps at least. So there's that. And again, just, showing the way that they put this together, which I really thought, these are some pretty sophisticated, designs to be putting together. And so when I saw this, I ended up talking to one of the other lecturers in my department about maybe trying to develop a study to kind of try to quantify this. But before getting into that, I'll show a little bit of just the general feedback that we received from the students. I'm not going to go through this in a ton of detail, but just basically overall, it was very, very positive in most areas. I think the one tip we saw was like, some were hesitant on, is this a valuable part of my education? That's hit or miss there. But overall, really, really good responses from students in terms of, I think how they felt about, the course and the way that the course went out. But then we also wanted to do like that more legitimate study. And so what we did was there's also a second course that students take that is a traditional computer-aided design course that they're supposed to take at the exact same time as my course. And we just wanted to see how, from traditional versus my course, how they felt. Mohammed Felzapor is the co-author for my studies of this. So he teaches that CAD course, and I teach the Zelda course, and so we were able to get IRB approval or Institutional Review Board approval to basically conduct these studies with the students. And there we're basically comparing this CAD course to basically my Zelda course, and there are some differences. But we use a 5-point Likert scale, going from basically strongly disagree to strongly agree based on the answers. And there were 4 areas that we kind of grouped our studies around. So one is confidence and perceived difficulty. And so this particular case, basically, we're asking if it was more difficult to understand than you would like. So ideally, the students should be saying they disagree or they strongly disagree, hopefully. But to be honest, in terms of like presenting the data, this is like a really annoying way to present it. So everything else that I present, agree or strongly agree is good and red is bad. So after this. And so, this is one where we're asking about, student confidence that they felt that they could learn the content as they work through it. And so these were overall very positive results to see. We also looked at attention and curiosity. And again, this is all self-reported. And so, asking students, if this course has stimulated their curiosity. And so here we found really strong feedback from the Zelda course, especially compared to the CAD course. And then learning something that's surprising or unexpected. Again, some really encouraging results from the Zelda course, versus the CAD course. And then just about the in-class activities helped keep my attention. I wasn't super surprised that, playing Legend of Zelda would keep their attention, more than maybe like a CAD lecture. But that was kind of reflected in the results in the studies. In terms of relevance and connection, so this is something that's a little bit more ambiguous, but how the content was related to things that students knew about. The content of this course is relevant to my interests. I was surprised actually that this was as high as it was because there were a lot of people who just like hadn't had video game experience, but maybe they were interested and just hadn't had an opportunity, to buy a Switch or had time or whatever that might be. And then this was their explanations or examples of how people use the knowledge in this course. To be honest, I thought we would have a rougher go of it with my Zelda course for this. I guess like I wasn't confident that I designed my course around this particular question, but still it was overall a positive response. But for the students who strongly disagreed, like I actually agree with them. So yeah. And then in terms of enjoyment and motivation, this is something where one would hope that that's the benefit of this, that completing the exercises and so forth left them with a feeling of accomplishment. That was actually reflected for both, which I think is great. I enjoyed the course so much. I would like to know more about this topic. This is another one where we had some encouraging results. And then again, I really enjoyed studying this course. The Zelda course, certainly outperforming the CAD course as one would expect. So I think the benefit here is that kind of the worst case scenario we saw for the Zelda course was that it was neutral, but everyone else either agreed or strongly agreed. And typically the vast majority of the class strongly agreed, which was a positive result to see. I think there are still opportunities for where this course can go. Right now, it's only a 1 credit course that's 50 minutes a week, which is very little time, for a course. And I think there are some fun things that can be seen in terms of using this as a way to better understand physics, or even just, create experiments that you could not have created any other way. If you ask someone to learn about how a spring works in real life, people have done that for, generations upon generations, so they can just like look back and see it. But here in this game, basically, you can't do that. And so what you end up finding is that there are certain laws of physics that are totally different in the game. So, for example, in this case, normally you can't increase energy of a system without putting energy in. But somehow that happens in the game, which is where their physics breaks down. But even just like uncovering those laws, I think is really interesting. And so I still think that there's potential to leverage that part of the game to help students get a sense of what it was like for the early physicists to learn about the world and the natural laws. But for now, basically, this was the very first actually study like in the field of like education, engineering education, to use an entertainment video game as is for undergraduate engineering education. And the preliminary results show definitely a lot of benefits so far in terms of attention, curiosity, relevance, and enjoyment for the students enrolled in the course versus that other CAD course. Uh, Absolutely, it's a great start, but there's no question that we would absolutely love to move on to additional studies where we have larger student cohorts and better controlled studies to make sure it's like similar student types and so forth. But as it is, like this is still, I think, a really great start in terms of investigating this. And so with that, I think we're solid on time, and so we can open up the floor for questions. Thank you.
I'll ask the first question and then hopefully people won't feel so shy. So the example that you provided for a bio-inspired robot was a flying monkey, but I guess I'm wondering, like, just in general, what constitutes a bio-inspired robot?
So a lot of the students ask the same question, what is bio-inspired? And so there's kind of two ways you can approach it. So it's one, it has to look like something, or it has to move like something that is living. And so mine was, I don't care how it looks, but I needed to move. I should have movements that reflect something in biology, which should be gait, for example, or so forth. So that's why, like, the thing with like the two hands, like, it doesn't really look like a monkey, but if you think about what a monkey's arms look like as they're moving, like that does, or an ape. And so that was kind of where we were targeting for that. To be honest, like, yeah, again, it's a one credit course, so how serious students took that, is hit or miss. But that was the intention with the assignment, is that you should be able to show a video of an animal and the movement should be reflected.
Got it.
I had a question. Thanks. That was super interesting. I was just wondering, are there other courses like this, like at other universities where they're using this game-based model?
So the versions that are similar are from like the very beginning, there was like that example of like using the modified Minecraft game
Mhm.
uh, to do it. But outside of that, I haven't seen anything using an entertainment video game like this anywhere. It's now been 2 years in a row at the American Society of Engineering Education annual meeting, and there's still nothing like it, unfortunately.
Oh, okay. That's a great idea.
But I think it would be great. I will mention, right? So one of the things that I got dinged for in terms of when I first presented the concept was that some of the people in the audience were concerned about the democratization of this kind of approach and how, expecting people to buy, switches and the game and the controllers and all of that. But actually, I think that's a little bit misguided when you look at how expensive some of the alternatives are. So to buy the CAD software that we typically use for this course, SolidWorks, that license is typically like 10K a year per computer station. And so everything all together for the whole course, we spent, I think, $2,000 or so for all the switches and so forth. But then that money is a fixed cost. So I've been using the same set of switches and games and everything semester after semester after semester after semester. And so I think financially, like it after you get over that initial, purchase, I do think actually the finances work out relatively well. And then also in terms of like simulation software to simulate the types of machines that we have here, I mean that is thousands of dollars a year. And also it takes a ton of time to get a simulation that looks anything like that. And so I think that like legitimately it has some strengths in that area as well.
Mhm.
Aaron?
Hi, Ryan. Yes. Thanks so much for this talk. It's really interesting. I'm part of a teen imprint of a science magazine. So coming into this, I'm very interested in hearing your thoughts about what engineering or physics concepts you feel the Tears of the Kingdom can demonstrate really well for kind of like high school students and students at that age level. And I'm like a diehard Zelda fan. I've been playing since the 90s, so I'll get all the references.
So, yeah, no, I mean, I think, I wouldn't say it's I mean, the physics have problems, right? I mean, so there are some, I don't know how much time you spent with like, building machines in Tears of the Kingdom, but one of the things that immediately you'll find it makes no sense, right, is you'll have one wheel and that uses, let's say, like, 1 unit of energy, like one of the batteries that you see, per minute or whatever it is. And then if you add a second wheel, the game gives you a benefit of scale. So the second wheel now only requires an extra like half of that first one. And each additional one you add also is just a half. So the very first wheel you include, that's what really hits you from an engineering or from an energy standpoint. But then each one after that, that doesn't make any sense. That's not how it works. Like if in real life, if you were to do that, you add additional motors, you need additional power for each one of those. So that, immediately isn't super relevant. In terms of the physics, I think I mentioned like the one that's problematic is the energy coming out of nowhere in terms of the behavior of like the spring and things like that. The reason I moved away from the water-based aquatic robots is the water physics makes no sense. So the water ones are really moving very fast and like hitting the water a lot, but they're moving almost nowhere. So that like there's water-based physics that just aren't replicated. And so I would say it's not ideal in terms of teaching physics. What I think it is great for is teaching students how to basically prototype, test, redesign, and kind of go through that iterative process that isn't necessarily a hard science, but it is very important for engineering because that is in a lot of places the workflow where, learning how to prototype and learn from those prototypes and investigate. And so I think that was the main thing that I think it's beneficial for. And then the other aspect is that genuinely the interface that it uses for building things, the auto hand, yeah, and so basically that is almost identical to the assembly module in SolidWorks. And so I think help, so even for like my kids who are only like 6 and 4, like I'm trying to like push them to just get experience with it because they don't realize it. But when they eventually start using the assembly module in SolidWorks, they're going to have a huge leg up because they're like, oh, it's just the same as, Ultrahand, And so, yeah, so I think those are kind of my thoughts on that.
We have a question that Jessica Frost left in the chat, so I'll read it out for you, Ryan. So she says, could you talk more about the similarities with how this type of design building supports future foundations with building larger design models and 3D printing? And then the follow-up question is, do you hear qualitative feedback from students who really enjoy the course and then it helped them decide on a new focus or course to pursue with engineering or robotics, etc.?
Okay, all right. So two parts to that question. I'm gonna just like open up the chat for myself because I'm always very bad at remember that. All right, so larger found. So I would say that actually the similarities are pretty significant in terms of the building structures in computer-aided design, but also I structure the course that way where we have a lot of assignments where the students are asked to kind of build these models that are very unusual, right? So in conventional CAD courses, like students build like a hammer or they build like a screwdriver, stuff that, or like, the basics that you might see in like an engineering 101 kind of course. Whereas I think what's fun about asking them to build these interesting models or these interesting parts from a game is that it makes them tackle geometries that they don't typically see that early, just like very weird geometries that were designed because they look cool in a game, not because, they're necessary as they have curvature and so forth, that for traditional manufacturing might not be so critical. But for additive manufacturing or 3D printing, that's a case where because you have that benefit where you can actually build things with these really sophisticated structures that I personally in my lab, like I need students who have that kind of experience where they can actually build these really wild structures that actually have benefits in terms of their application. In terms of qualitative feedback, I mean, it's been very positive. I've had a number of students who took my course and either joined my lab or they joined. We have something at University of Maryland that was recently, it's an educational initiative that's called the Vertically Integrated Projects Program, or VIPS. And so I've had a number of students, actually that you saw today in some of these videos, who they took this class and then a year later ended up joining my VIPS team to work on soft robotics that can play video games. So in terms of switching focus, that's hard to say, but I will say that students have kind of like unanimously been like really happy with the course in terms of enjoying it. Except for there's like a few students who, there was one student who took the Switch home and never brought it back. And so he really messed with the other students in his class. So that team had some challenges there. But outside of that, it's been really enthusiastic, I think, responses. And I do think that students who maybe didn't feel so comfortable with computer-aided design before the course felt a little bit more comfortable because they had made kind of these really wacky things in CAD, and all of a sudden they're like, oh, I can do that. I can do the assembly. Maybe I can, kind of target applications related to computer-aided design. So that's something that several students have said explicitly to me, which has been, I would say, like rewarding.
Anyone else has questions? I kind of had a very similar question, or even kind of a follow-up to that. Did you think that the students in the course were more bio-inspired or more game-inspired? And I guess that what I was kind of wondering is whether there was feedback or follow-up on what they were inspired to do or research after the course. I know it seems like they were taking the courses, but do you think it informed what they were doing in those courses?
I mean, it's hard to say because I mean the students in the course are very young, beginning of second year, these students typically are not participating in research yet. And even the course itself, right, is about to hit 2 years old soon. So we haven't even had like our full group of students graduate from Maryland yet, who from that very initial cohort. And so I haven't got to do like any kind of like long range tracking. Um, I it's fun, so I guess from like the original semester, I really thought it was going to be a bunch of people who are gamers. Like that was my assumption. And it's turned out to be really untrue. It's been a lot of people who just don't have access or don't have time to Nintendo Switch or playing games that they end up, it sounds like they're taking my course partly just like to be able to get some time with this game that they heard about. There's also a bit of, students talk to each other and they have courses and instructors that, they think are fun or whatever. So there's a little bit of that. But I think, I guess my hope is that the students might take it for those reasons and not even realize that they're building up these skill sets in computer-aided design and machine design and robotics which is what you want, right? The same way that I mentioned, like, I get on the treadmill, but because I'm so, into the television show that I'm watching, it completely, I don't even realize that I've walked, whatever, several miles because I'm just so focused on that. And I hope the same thing for the students where they've built up these competencies and all of a sudden they're like, oh, wait a second, I can CAD that. I've CADed things that are way harder than that. So yeah, I don't know if that kind of answers parts of your question.
That did. I knew it was early. I just sometimes I just if there were certain projects that they were leaning toward in some of the later uh, courses, but that'll come. We'll see.
So I also teach a fourth year class, which is a 3D printing class. And so I think this most recent semester is the first one that actually I saw students from my Zelda course who were able to enroll. They had made it far enough along that they could enroll, but I don't remember how they did in that course, like grade wise or anything like that, or which projects they chose for the 3D printing class. Um, but I will try to maybe pay a little bit more. I mean, this upcoming semester, I have a feeling I'm going to have some more students from that first year, because this would be exactly when they would do it, where they were a second. The first semester of their second year was when I first released the course, and this would be the first semester of their fourth year. Should be taking my 3D printing class, and so I will pay a little bit of extra attention to any of those students and see how it goes.
Well, thank you so much for sharing. This has been great.
Thank you.